Hi, welcome to our first Level 3 probability distributions video. We're going to introduce some key ideas of probability to introduce this topic. Now we know in mathematics probability is used to investigate chance. It's measured on a scale from 0 to 1 and it's written as a fraction, decimal or percentage. When data is collected from an experiment or an observational study, it can be modelled by a probability distribution. These are graphs or tables. Here's a probability distribution for rolling a die 20 times. On the y-axis, we have the frequency, how many of each of the outcomes, how many of each of the numbers comes up. But we can represent the same information with the same graph, but instead of frequency, we have probability or the relative frequency on the y-axis. What's the probability of each outcome occurring? Now, when we have a table or a graph that has frequency, we call it a frequency table and frequency graph. But if we change it to a distribution where we have probability, we call it a probability table and probability graph, and it has other names such as probability distribution table or graph, or relative frequency table or graph. A random variable is a variable whose values cannot be predicted but are determined by the outcome of an experiment or an observational study. Now, there are three we're going to talk about, and you've come across these in your statistics journey. A categorical random variable is a variable which describes something, and they're usually words or labels. For example, gender is a categorical random variable, and we can describe gender as male or female or non-binary or gender diverse, and so on. Discrete random variables are variables which are counted, and therefore the values must be whole numbers. For example, the number of pets owned by students. And we also have continuous random variables, which are variables which are measured. Therefore, the results can be whole numbers and decimals, any number. All right, let's talk about the probability notation you need to be familiar with for this topic. When I say P bracket X equal to 4, the P represents the probability, and inside the brackets is the event that we're trying to determine the probability of. So P bracket X equal to 4 says what's the probability that we get X is equal to 4. Let's talk about our inequalities, because this gets some students a little bit stressed. So let's pop our inequalities up here just to remind us as we go. So P bracket X greater than 4. Now, it depends whether you have continuous or discrete data. For continuous, we have an open circle on 4 because we're not allowed to include 4, but we have any number bigger than 4. But if it's discrete data, it must be whole numbers, and so we can't include 4, so we have to have our first whole number at 5, 6, 7, 8, 9, and so on. But if I say greater than or equal to 4, for continuous, I can close up my circle for 4 and any number bigger, so it includes 4 and bigger. But for discrete, I can include 4, so I can have whole numbers 4, 5, 6, 7, 8, and so on. When I say probability X is less than 4, for continuous, I have to have an open circle on 4, because I'm not allowed to include 4, and any number less than 4. And for discrete, I must have whole numbers, so I must have any number less than 4. The first whole number is 3, 2, 1, 0, negative 1, and so on. And when I say X is less than or equal to 4, for continuous, I can close up my circle on 4 because I'm allowed 4 and any number less than 4. And for discrete data, I must have whole numbers, so it must be 4 and 3 and 2 and 1 and 0 and any number less. And finally, this is the notation to basically mean any number between 1 and 4, but I don't include my equal sign at first, which means for continuous, I can have any number between 1 and 4, but I've had open circles on 1 and 4 because I'm not allowed to include 1 or 4. And for discrete data, I can only have whole numbers. The only whole numbers between 1 and 4 are 2 and 3. And when I do include my equal, less than or equal or greater than or equal signs, I can, for continuous, close up my circles and have any number from 1 to 4 inclusive. And for discrete data, any whole number between 1 and 4 includes 1, 2, 3, and 4. All right, well, that's our first video done. So thanks so much for watching.